Hello everybody, the topic which I am going to explain you in this video today is about the classification of laser systems. Since this topic will not involve any mathematical derivation or any explanation of a diagram or something, uh, I'm going to actually kind of read out the notes of this topic to you. So the first statement which I want to make is all the laser systems are actually classified into classes like 1, 2, 3 and 4. That is class 1 lasers, class 2 lasers, class 3 lasers, class 4 lasers. And this classification is actually based upon the wavelength of the laser output and also the power of the laser output. And this is done by American National Standard Institute, ANSI, and International Electrochemical Commission, IEC. And this classification, as I said, will be actually class 1 lasers, class 2 lasers, class 3 lasers, and class 4 lasers. Especially, we'll be seeing class 1 lasers, class 1M lasers, class 2 lasers, class 2M lasers, and class 3R, and the same kind of label on the thing. It will be also class 3B lasers, and finally class 4 lasers. So let me talk about class 1 lasers first. The lasers that belong to this class are safe under all conditions of normal use. They are safe to use actually, and seeing with the naked eye or with the help of a magnifying optic is safe. You can look at them with the help of a telescope or maybe a microscope also, and it will be actually kind of safe. But it may be dangerous if you see them through an optic of large aperture. That means if you have a lens of larger aperture and if you are using that to look at these beams, then that may be dangerous. And for visible lasers, the lasers of this category usually have power less than 0.39 milliwatt. That's what I wrote here, 0.39 milliwatts of power. And these lasers can be seen either outside or inside of some devices like a CD player or DVD player. Inside them you will have the lasers of this class. And these lasers are safe for long industrial viewing also. You can look at them for a long time and they're still safe. This is it. I want to talk about class 1 lasers, and they usually have this safety label, class 1 laser product. This is the safety label of that laser. And coming to the next class of lasers, which is class 1M lasers, they usually have these safety label. It will be actually in a kind of a rectangular box, and I think usually this is actually in red in color. So it reads laser radiation do not view directly with optical instruments, and it also says class 1 laser product. So the lasers that belong to this class are safe for all conditions of use except when passed through a magnifying optic like a lens. They are safe to actually look at them, but if the laser beam passes through an optic like a lens, then it will become actually kind of focus and giving rise to intense kind of light concentration that may be actually harmful to your eyes. And these lasers may have an output beam of large diameter or beam with divergence. These lasers usually come with, they can have large aperture kind of thing, we can say large beam diameter. They come with large size. And for visible lasers of this class, the output power is of the order of 0.39 milliwatts. So that's what I wrote here. The output power of laser 2M class lasers is actually of the order of 0.39 milliwatts. And this is actually safe for unaided eye exposure. You can still look at them when you're not using any optic, they are still safe to look at. And this is what I want to talk in this class. And let me go into the next class of the lasers, which is class 2 laser systems. And in this we usually have this as the safety label, that is actually laser radiation do not stare into the beam, and the third line will be class 2 laser product. And the laser systems that belong to this class are of visible wavelengths. They are actually visible lasers with the wavelengths of 400 to 700 nanometers. They are visible lasers, and the output power of these will be less than 1 milliwatt. The output power will be less than 1 milliwatt with continuous emission. They are actually continuous emission lasers. And if viewed for about 0.25 seconds, which is actually blink reflex, we actually try to respond to a danger or something with our eyes, that is for 0.25 seconds. I mean, within 0.25 seconds we respond to some kind of danger that our eye senses. That's what is called blink reflex. So if we actually view these lasers for about that much of time, they are still safe. And there is something called NOHD, which is actually no ocular hazard distance. That means if you actually look at the beam from certain distance, then they are actually kind of safe. And that distance for a laser of this class with power 0.99 milliwatt with a beam divergence of 1 milliradian is 7 meters. That means if you look at a laser of 0.99 milliwatts of power with a divergence of 1 milliradian, sorry for this, 1 milliradian, from a distance of 7 meters, then you are still safe. Your eyes are still safe. And the examples of this kind of lasers are actually laser pointers, the ones which you use for PPT presentation, and some measuring instruments. We usually use them for alignment of optical setups in optics labs. Anyways, this is what I want to talk in this class of lasers. And let me go to the next class of lasers, which is class 2M lasers. And they usually have this safety label, which is laser radiation, the first line of that. And the second line of the safety label will be do not stare into the beam or view directly with optical instruments. And the third line will be class 2M laser product. And these lasers have power less than 1 milliwatt. That's what I wrote here, the same kind of power. But they are safe to view for 0.25 millisecond, which is blink reflex time, without optical instruments. You can look them without optical instruments, but if you use optical instruments, then it's dangerous. And they have large diameter or divergence. The difference between class 2 and class 2M is class 2M beams will come with larger diameter or divergence. And class 2 and class 2M lasers actually belong to visible class. The wavelength will be actually visible, and they don't involve IR, infrared radiation lasers, or maybe UV, ultraviolet laser radiation. So these 2 and 2M lasers are strictly for visible lasers. And that's what I want to talk in this class, and then I'll go into the third class, the next class, which is class 3R laser systems. And the safety label for these will be having 3 lines like this enclosed in a rectangular box. The first line will be laser radiation, second line will be avoid exposure to beam, and third line will be class 3R laser product. And these lasers emit output of output power of 1 to 4.99 milliwatt, the first thing, 1 to 4.99 milliwatts. These lasers are safe if handled carefully with a restricted beam viewing. They are actually kind of safe if you handle with restricted beam viewing. If maximum permissible emission is exceeded, they may be at risk of injury. I mean, if you look, sometimes they can be injured also. Injurious also. And NOHD, that is actually no ocular hazard distance of laser with power 4.99 milliwatts with 1 milliradian divergence is 16 meters. That means if you look at a laser of 4.99 milliwatts power with 1 milliradian divergence from a distance of 16 meters, then you are still safe. Examples for this kind of class are visible lasers, as I said, with power close to 5 milliwatts. This is what I want to talk in this class, and I want to go into the next class, which is class 3B lasers, and the safety label for those also will be again same as that for 3R, but in place of 3R we get 3B. So the safety label will almost be same. And direct weaving of these lasers is dangerous, but diffuse reflections from a paper are not harmful. These class 3B are actually kind of powerful lasers in a way, and you should not see them directly, but if you look at the diffuse reflections, then it may be okay. The no ocular hazard distance of course, I did not say that these will have power from 5 to 499 milliwatts. Output power of the laser beam will be between 5 milliwatts and 499 milliwatts. And the no ocular hazard distance of 499 milliwatts beam with 0.5 milliradian divergence is 320 meters. That means if you look at 499 milliwatts power beam, which has got a divergence of 0.5 milliradian from a distance of 320 meters, then you are still safe. It's you may not become a blind person. And for the safety of the user, these laser products will come with something called protective eye. The user should use protective eyewear, the goggles, and these will be actually equipped with something called key switch. Whenever you're using the laser, you should actually turn on the laser with the help of a key, and that is actually for the safety. You can take the key and it won't be actually kind of operational anymore. And these will also have something called safety shutter. That means whenever somebody is entering the lab without your permission, then if the laser is on, then automatically, when the door is open, this laser will actually kind of stop the radiation. That's because of something called laser shutter interlock. So there is something called interlock, safety interlock, which is inside the laser. These will have that. And let me go into the next class of laser, which is class 4 laser system. I don't know whether you can see because I was holding my papers like this, but anyways, the last class of lasers is called class 4 lasers, and they will have the safety label like this with red kind of red color lines reading laser radiation. The first one. The second line will be avoid eye or skin exposure to direct or scattered radiation, and the third line will be class 4 laser product. And the lasers of this class are the most dangerous ones. And for visible lasers, the output power is more than 500 milliwatts. The power is more than 500 milliwatts. And these can burn skin or cause a permanent eye damage. I mean, if you exposed to them. And these lasers may be able to ignite some combustible materials. You can use them to actually kind of trigger a fire. And the scattered beam from these lasers is also harmful to see. I mean, even the scattered beam is dangerous. The no ocular hazard distance of a 5-watt laser with 1 milliradian divergence is 500 meters. That's half a kilometer. So you can look at 5 watts of laser which has got 1 milliradian divergence safely from a distance of 500 meters. But if you're less than that, then you're at a danger. And these lasers are equipped with a key switch, as I said, for the safety of the people. You can actually turn it off and go, and nobody can actually turn it on and use until they got the key. And they also have got a safety interlock. That is actually when somebody enters the lab in which we have got this laser accidentally, then as soon as the door is open, this safety lock will put the laser to off mode. That means there is no laser radiation in the room. So this is it in this thing, and we can find these class of lasers in industrial areas to cut, to weld materials, and in scientific equipment, I mean scientific labs also, and in military use. That's because, as I said, they're dangerous, so you can harm your enemy with the help of these lasers. Anyways, these are the things which I want to talk in this video, and I hope I made some useful points, and I will meet you next time with some other video. Bye bye for now.